Hare Krishna, this is my 8th video, and today again I am continuing the derivative of a inverse trigonometric function. In the last video, in the part 1 and part 2, we have taken, that is the derivative of a inverse trigonometric function. There we have studied the theorem, the 6th proposition, that is we have proved the derivative of a sine inverse x, cos inverse x, tan inverse x, sec inverse x, cot inverse x and cosec inverse x, right? And also we have taken the basic problem, that is on the sine inverse x, cos inverse x, tan inverse x, sec inverse, cosec inverse and cot inverse x with the help of a chain rule, isn't it? Now again I have to, in this session, again I have to take the inverse trigonometric function, the derivative of a inverse trigonometric function, and again the problems, variety of a problems now I am going to take, right? Because this chapter, that is derivative, it is vast, and the inverse trigonometric function, it is too lengthy. Therefore you have to take the variety of a problem, then and only then you get the clear idea about the inverse trigonometric function. So I am going to start, that is the problem. See here, problem depending upon formula, that is tan inverse x plus tan inverse of y, it is equal to tan inverse of x plus y divided by 1 minus x, isn't it? Second formula, tan inverse x plus minus tan inverse of y, it is equal to tan inverse of x minus y divided by 1 plus x, isn't it? Now here, this is first type number 1, type 1, first one, y is equal to tan inverse of 1 plus sin x divided by 1 minus sin x. Second one, y is equal to tan inverse 1 plus log x, 1 minus log x. Third one, y is equal to tan inverse 1 plus e raised to root x, 1 minus e raised to root x. Here again fourth one, y is equal to tan inverse of 1 plus sec square 4x, 1 minus sec square 4x. Right? And the fifth one, tan inverse 1 plus cosec cube x, 1 minus cosec cube x. See, so write down all these 5 problems here yourself and see what is this formula. First, try to understand this formula. If your problem, it is in this form, what is the form? Tan inverse x plus y divided by 1 minus xy. What is the form? First you have to understand. It is carefully, isn't it? 1 it is strictly there. If you observe this, in this formula 1 it is strictly there, and whatever the term added, ज्या काही 2 term add केलेले आहे, here there is the multiplication of a 2 term, isn't it? And if there is a plus in the numerator, strictly minus it is in the denominator, right? So 1 should be strictly there, and whatever the term added, we want here their multiplication, their product, isn't it? Suppose 2x plus 3x, and here we want 6x square, 4x plus 3x, that is 7x square here you want. So the formula is 1 should be strictly there, whatever the term added, the multiplication of these 2 terms should be in the denominator here, isn't it? So क्या सोचना है अपने को? First you have to decide the formula, first you have to think about the formula and what is actually the formula. देख लो, 1 it is strictly there, 1 रहना ही चाहिए, और जो कुछ 2 term add कर रहे हैं, whatever the term added, जो भी 2 term add कर रहे हैं, here we want their multiplication, उसका multiplication इधर आना चाहिए, right? If your function, if your problem, it is in this form, then directly you can write tan inverse x plus tan inverse of y. Instead of doing, or instead of applying the chain rule here, you can apply the chain rule here, because this is the simplified form of this formula. Tan inverse x plus y divided by 1 minus x5. Directly you can write as a tan inverse of x plus tan inverse of y. And this is the simplified form, and you can directly find out the derivative easily of this simplified form. Right? Therefore, a very simple here. Y is equal to tan inverse 1 plus sin x. You also construct yourself so many problems, isn't it? Now see, what it is strictly there. Whatever the term added, which two term are added? 1 plus sin x. इसका multiplication क्या आता है? 1 into sin x, that is sin x. That sin x is here. Whatever the term added, we want its multiplication, it is in the denominator. यहाँ चाहिए. तो है 1 into sin x is here. Therefore, directly this you can write as a C. Tan inverse of 1 plus tan inverse of sin x. Right? Now you can easily differentiate. See, this is y. Therefore, dy by dx, it is equal to ddx of, that is tan inverse of 1 plus ddx of tan inverse of sin x. Again, if you observe this, tan inverse 1, it is totally independent of x, considered as a constant. And what is the derivative of a constant function? That is 0. Right? Again, here you have to apply the chain rule. Here you have to substitute u. What is the derivative of a tan inverse u or tan inverse x? 1 upon 1 plus x square. Means what is the derivative of a tan inverse u? 1 upon 1 plus u square, means 1 upon 1 plus, what is u? Sin x, that is sin square x. And you have to take ddx of sin x. Right? Therefore here, what is the derivative of a sin x? That is equal to cos x. And here 1 plus sin square x. Very simple. Right? In this way, you can do all the problem. I will take the fifth one. Right? Fifth problem I will take. And the remaining 2, 3, 4, you can do yourself. Isn't it? So, this is the type number 1 depending upon this formula. Right? On these two formulas, the type number 1, and I have given the 5 problem to you. I have solved, that is the one, isn't it? First one, and the solution of a first one, it is cos x divided by 1 plus sin square x. Now I will take the fifth one, last one, see. Last one, again very simple. You can do yourself. Tan inverse 1 plus cosec cube x divided by 1 minus cosec cube x. Right? Again 1, it is strictly there. And whatever the term added, we want its multiplication here. And this is already there, isn't it? 1 into cosec cube x, that is cosec cube x, and this term, it is already there. Therefore, you can apply the formula again like this. See, this you can write as a tan inverse of 1 plus tan inverse of cosec cube x, isn't it? Now again, dy by dx, it is equal to ddx of tan inverse of 1 plus ddx of tan inverse of cosec cube x. Right? Now again, it is independent of x, considered as a constant, and the derivative of a constant function, it is 0. Again you have to substitute u. What is the derivative of a tan inverse u? 1 upon 1 plus u square, means cosec cube x whole square. Again you have to take ddx of whatever the u, that is cosec cube x. Right? Now here 1 upon 1 plus cosec to the power 6. Right? 3 to the 6. And here again you have to use the power formula. What is the derivative of x to the power n? N into x to the power n minus 1. This also you have to write as a ddx of cosec x whole cube. Therefore u cube, what is the derivative of u cube? That is 3u square, means 3 cosec square x. And again you have to take the ddx of cosec x. Right? Now see here. This is 3 cosec square x. I will write here at the upper side of the board. 3 cosec square x, 1 plus cosec to the power 6. And again here, what is the derivative of a cosec x? The derivative of a cosec x, that is minus cosec x into cot x. Right? Now here you have got 3 into minus 1 minus 3. Cosec square x into cosec x, you can write as a cosec cube x. This is cot x divided by 1 plus cosec to the power 6. isn't it? So this is about the problem, that is the inverse trigonometric function, isn't it? So the problem, it is depend upon this formula, tan inverse x plus tan inverse of y is equal to tan inverse of x plus y divided by 1 minus xy, and this is the result, right? Again, the same type number 2, see the problem type number 2. Now the remaining problem 2, 3, 4, you can do yourself, isn't it? Again, I will write the type number 2, see. Y is equal to, first one, tan inverse 1 plus x sin x divided by x minus sin x, right? Second one, y is equal to tan inverse 1 plus root x log x divided by root x minus log x. Here again, third one, y is equal to tan inverse of 1 plus x square into sec 4x divided by x square minus sec 4x. Here again, fourth one, y is equal to tan inverse of 1 plus x e raised to x divided by x minus e raised to x. And the fifth one, y is equal to tan inverse of 1 plus, that is x root x, here again tan 3x divided by x root x minus tan 3x. Right? Now again, this problem you can write as a, you can give the minus sign here, plus sign here, isn't it? Here, if there in the numerator minus, then you can write denominator, that is the plus, right? So in this way also you can take the problem, right? इसको ऊपर नीचे कर सकते हैं साइन, इसको माइनस भी कर सकते हैं, इसको प्लस भी कर सकते हैं, isn't it? So I have taken all the plus here. You can take minus sign also. The same procedure you have to follow. Now see, y is equal to tan inverse 1 plus x sin x divided by x minus sin x. Now according to this formula, what should you require? Here you want x. Sorry, here you want 1, isn't it? 1 should be strictly there. And whatever the term added, here we want their multiplication. This is the formula, isn't it? What is given in the formula, 1 should be strictly there. And whatever the term added, here we want their multiplication in the denominator, in this place, isn't it? So again, since here we want 1, then and only then you write tan inverse x plus tan inverse of 1. Therefore here we want 1, therefore divide both numerator and denominator by what is x. X से divide करना पड़ेगा. Therefore see, tan inverse of, here you have got 1 by x. X से इसको divide किए तो sin x. Here whenever you divide it with x, you will get 1, and when you divide it to sin x, you will get sin x divided by x. Now see, your problem, 1 it is strictly there. Which two terms are added? 1 by x plus sin x. What is the multiplication of this? 1 by x into sin x, that is nothing but sin x divided by x. Is it there? Is the multiplication of a two terms are there or not? There is the multiplication of a two term, right? Therefore your problem, it is in this form. So whenever your problem, it is in this form, the direct result you can write as a tan inverse of x plus tan inverse of y. Here also you can write y is equal to tan inverse of 1 by x plus tan inverse of sin x. Very simple, isn't it? No, again it is little bit. Suppose you substitute u, then the derivative of a tan inverse u, that is 1 upon 1 plus u square, means 1 upon 1 plus 1 by x whole square. Again you have to take the ddx of 1 by x, that is little bit complicated, isn't it? So this you can convert in the form of a, now tan inverse converted into cot inverse by taking the reciprocal of angle. You can write cot inverse of x plus tan inverse of sin x. Now the simple derivative here, dy by dx. What is the derivative of a cot inverse x? Minus 1 upon 1 plus x square. Here again you have to substitute u. What is the derivative of a tan inverse u? 1 upon 1 plus u square means sin square x. And what is the derivative of a sin x? That is equal to cos x. So this is the result. Isn't it? Very simple, right? If your problem, it is in this form, this is the second type, 1 plus x sin x divided by x minus sin x. Here we want 1, strictly 1, according to the formula. Therefore, divide both numerator and denominator by what is x. When you divide it with x, here you have got 1 by x, here you have got sin x, x divided by x, that is equal to 1, or sin x divided by x, that is sin x divided by x. Got it? No. Again, since the multiplication of a two term is there and when it is strictly there, this formula you can write in a simplified form, that is tan inverse of 1 by x plus tan inverse of sin x. Now tan inverse of 1 by x you can write as a cot inverse because it is little bit complicated. Therefore, tan inverse you can convert it into cot inverse by taking the reciprocal of angle, that is x, and tan inverse sin x remain as it is. Now find out the derivative very easily, isn't it? So this is about the first. Now I will take the last one. The remaining, that is 2, 3, 4. You can do yourself, isn't it? Only I will give the first and the last. Any two problem, I will give. See, right? If any difficulty are there, please comment, suggestion, give me the suggestion, right? Through the comment box. So I will take the fifth one here. See, y is equal to tan inverse of 1 plus x root x tan 3x divided by x root x minus tan 3x, isn't it? So first you have to write x root x. How will you write this? Because x root x, this is the one term only. You see, these are the two terms, but actually this is the one term, because x root x you can write as a, what is the power here? 1. And what is the power? If you eliminate this root, then what is the power here? 1 by 2. When the same base is same, you can add indices. Therefore, in place of this, you can substitute what here? X to the power 3 by 2. Therefore, first to substitute 1 plus x root x, you can write as a x to the power 3 by 2 tan 3x divided by x to the power 3 by 2 minus tan 3x. Right? Again, what do you want? Here we want 1. Right? Here we want 1. Therefore, what you have to do? Divide both. Divide both numerator and denominator by x to the power 3 by 2. Isn't it? Now when you divide it with x to the power 3 by 2, that is tan inverse. Here you have got 1 upon x to the power 3 by 2. Sorry. Here tan inverse. And when you divide it, you have got here 1 upon x to the power 3 by 2. Here x to the power 3 by 2 get cancelled. You have got tan 3x. Here again x to the power 3 by 2, x to the power 3 by 2 get cancelled, here 1. And here again tan 3x divided by x to the power 3 by 2. Again, your problem, it is in a standard form. One, it is strictly there. Whatever the term added, their multiplication is there. Tan 3x into 1 upon x to the power 3 by 2, it is nothing but tan 3x divided by x to the power 3 by 2. Therefore, again, the simplified form of this, y is equal to tan inverse of 1 upon x to the power 3 by 2 plus tan inverse of tan 3x. Right? Now, here I will write. Now again y is equal to, what you can write here? That is tan inverse 1 upon x to the power 3 by 2. You can write as a cot inverse, taking the reciprocal, right, 3 by 2. Here again, tan inverse tan get cancelled, and what is remain 3x? Again see, dy by dx. What is the derivative of a cot inverse u? That is minus 1 upon 1 plus u square, means minus 1 upon 1 plus x to the power 3 by 2 whole square. And what is the derivative of x to the power 3 by 2? That is 3 by 2, x to the power 1 by 2. And what is the derivative of a 3x? that is equal to 3. Therefore, this you can write as a minus. This is 3 by 2. X to the power 1 by 2 you can write as a root x. Here again 2 get cancelled. 1 plus x to the power 3 and plus 3. This is the result, isn't it? This is about the fifth problem again. Very simple. Here we want 1. Therefore, here you have to divide it with x to the power 3 by 2. Because x into root x, it is nothing but x raised to 3 by 2. When you divide it with x raised to 3 by 2, here you have got 1 upon x to the power 3 by 2. Here you have got tan 3x. Here you have got 1. And here you have got tan 3x divided by x to the power 3 by 2. Now your problem, it is in a standard form. Therefore, 1 it is strictly there. And the multiplication of this two term is here. Therefore, directly you can write as it's a simplified form. Tan inverse of 1 upon x to the power 3 by 2 plus tan inverse of tan 3x. Right? Again, tan inverse you can write in the form of a cot inverse by taking the reciprocal of angle, that is x to the power 3 by 2. And tan inverse tan get cancelled. Here you have got 3x. Again here, what is the derivative of a cot inverse u? Minus 1 upon 1 plus u square, means 1 upon 1 plus x to the power 3 by 2 whole square. And again you have to find out the derivative of x to the power 3 by 2, that is 3 by 2, x to the power 1 by 2. And what is the derivative of 3x? That is 3. Now 3 by 2 remain as it is. X raised to 1 by 2 you can write as a root x. This 2 get cancelled because the power it is multiplied to the power. 2 get cancelled. What is remain? 1 plus x cube and 3 remain as it is. So this is the second time, isn't it? The remaining 2, 3, 4 you can do yourself. That is quite easy, right? Now the third one, see. Third type also little bit the same. Type number 3. That is again depend upon this formula. Now the first one, y is equal to tan inverse 3 plus 4x divided by 4 minus 3x. Second one, y is equal to tan inverse 5 plus 7 sin x minus 7 minus 5 sin x. Here y is equal to tan inverse a plus b cos x divided by b minus a cos x. Right? Again, fourth one, y is equal to tan inverse 3 plus 4 root x divided by 4 minus 3 root x. And here again last fifth one, y is equal to tan inverse of 4 minus 3 log x, again 3 minus 4 log x, 3 plus 4 log x. Right? Now see, again very simple. Again I will take the third one and here fifth. Isn't it? I will take the third and the fifth one, see. And the remaining first, second, fourth, you have to do yourself. Write down the problem, isn't it? So the third one, y is equal to tan inverse a plus b cos x divided by b minus a cos x. Again, according to the formula, what do you require? 1 should you require here, right? Concentrate here. Here you want 1. Therefore, again you have to divide it with, divide by what you divide? Both numerator and denominator by what you do. When you divide it with b, tan inverse, you have got as a by b. When you divide it with b, you have got cos x. When you divide it with b, 1. And here again, a cos x divided by b. Again your problem, it is in a standard form. 1 it is strictly there. And whatever the term added, here you want their multiplication and this multiplication, it is already there. That is a by b into cos x. It is nothing but a by b into cos x, isn't it? So, what is the simplified form again? Tan inverse a by b plus tan inverse of cos x. Right? Again, dy by dx Again, if you observe this, tan inverse A by B, it is independent of x, considered as a constant, and what is the derivative of a constant? That is 0. Again, apply the chain rule. What is the derivative of a tan inverse u? 1 upon 1 plus u square, means 1 upon 1 plus cos square x. Right? And d dx of cos x, that is nothing but what here? Minus sin x. Therefore, your result, that is minus sin x divided by 1 plus cos square x. This is about the third one, isn't it? Now I will take the last one here. See, the last one. Very simple. Last one. Y is equal to tan inverse 4 minus 3 log x divided by 3 minus 4 log x. 3 plus 4 log x. Right? Now see. Again we want 1. Therefore divide both numerator and denominator by what here? 3. So divide both numerator and denominator by what here? 3. Now when divide both numerator and denominator by 3, you have got 4 by 3. When you divide it with 3, you will get log x. Again, when divided with 3, 1, and here 4 log x divided by 3. Again your problem, it is in a standard form. One, it is strictly there. Whatever the term subtracted here we want their multiplication. If you multiplied 4 by 3 to log x, 4 by 3 into log x, here already there, isn't it? Therefore, your problem, it is in a standard form. Directly you can write the simplified form, that is tan inverse of 4 by 3 minus tan inverse of log x, isn't it? Now again, very simple. Tan inverse 4 by 3, it is again independent of x, considered as a constant, and the derivative of a constant function, it is always equal to 0. Therefore, this is 0. Minus remain as it is. Again apply the chain rule. Here you have to substitute u. Tan inverse u means 1 upon 1 plus u square, that is log x whole square, and the derivative of a log x, that is 1 by x. Right? Therefore, your result, that is minus 1 upon 1 plus log x whole square into 1 upon x. Right? This is the fifth, isn't it? So again I have solved, that is what here, third and fifth, and the remaining, that is first, second, and the fourth, you can do yourself. Right? Now again, depending upon the same formula, I will take the type number 4. See the type number 4. See. Type number 4. First one, y is equal to tan inverse 7x minus 12x square. Second, tan inverse root x 1 minus 6x. Right? Again, y is equal to tan inverse root x again plus 20x. Again fourth one, y is equal to tan inverse 2x and 1 plus 15x square. And fifth, y is equal to tan inverse of 3x, and here again 18x square. See the problem. Again, write down the 5 problem here. Now I will take one by one. I will take the first and the third. Third or second also, isn't it? And the remaining problem you can do yourself. The first one, y is equal to tan inverse of 7x 1 minus 12x square. Now see the problem here. One, it is strictly there. But here we want the two terms such that, since there is a minus, here we want two terms such that there is a addition of a two term must be 7x, but the multiplication of a two term must be 12x square. So that 7x you have to adjust, you have to manage in a sum of a two term, so that their sum should be 7x, but their multiplication it is equal to 12x square. क्या करना है, ये 7x को एडिशन में कन्वर्ट करना है. ऐसे दो टर्म लेना है कि उसका एडिशन कितना आना चाहिए 7x और उसका मल्टिप्लिकेशन कितना आना चाहिए 12x स्क्वेअर. नेमकं काय करायचं आहे आपल्याला, 7x ला असं ॲडजस्ट करायचं आहे की त्यांचं ॲडिशन किती आलं पाहिजे 7x आणि त्यांचं मल्टिप्लिकेशन किती आलं पाहिजे 12x स्क्वेअर. व्हेरी सिंपल. विच टू टर्म यू कॅन कन्सिडर, 4 and 3, because 4x plus 3x that is equal to 7x, and their multiplication 4 3s are 12, 12x square, isn't it? In this way you have to adjust the term, isn't it? You have to manage the problem. Now this you can write as a 4x plus 7x, and again you have to see the carefully. When there is a minus, you have to decide always there are the two terms such that you have to add this. If there is a plus, then decide the two term is such that you have to subtract that term, isn't it? So there is subtraction, and here since there is a minus, here you have to think over about the addition of a two term. So 4x plus 3x that is equal to 7x, and here 1 minus 12x square. See the problem? One it is strictly there. The added term, whatever the two term added, their multiplication is here. Therefore, what is it's a simplified form, that is tan inverse of 4x plus tan inverse of 3x. Very simple. Now dy by dx. Here again this is u. Again this is u. Tan inverse u. What is the derivative of a tan inverse u? 1 upon 1 plus u square. The square of this 4x that is equal to 16x square. And what is this is u. Again you have to find out the derivative. What is the derivative of a 4x? That is 4. Here again 1 upon 1 plus the square of this. Again this is u. Tan inverse u. 1 upon 1 plus u square means 3x whole square, that is equal to 9x square. And what is the derivative of a 3x? That is equal to 3. Simple one, isn't it? Only see, according to this formula, how will you manage the problem, isn't it? When I have given the different type of a problem, you can decide the type, which type is there, isn't it? In book there are all the mixed problem, but I have divided this, isn't it, in a different type. So whenever I have given the different type, you can think of whether this type is here or not, whether this type it is in this problem or not. So you can decide yourself, isn't it? So that I have given the type of this problem, isn't it? काय होतं, वेगवेगळे जर टाईप दिले तर तुम्हाला जे प्रॉब्लेम आलं ते फर्स्ट यू हॅव टू ऑब्झर्व दिस. त्याला पहिल्यांदा ऑब्झर्व करा आणि कुठला टाईप आहे हे तुम्ही तुमचं डिसाईड करू शकता, राईट? बट सच अ टाईप यू हॅव टू remember, such a type you have to practice it, then and only then you can think over about the problem, right? Because there are the variety of your problems. So again, because only these two formulas, there are the 4 type of a problem, right? And again I have made the division of this, that is first type, second type, third type and fourth type, right? So I am taking here the third one. Again very simple, third one. See, y is equal to tan inverse root x divided by 1 plus 20x. Right? Now again you have to decide two terms. Since there is in the denominator there is a plus, you have to decide such a two terms, their subtraction must be root x and their multiplication is 20x. Therefore which are that two terms here? Right? Their subtraction must be what your root x and their multiplication is 20x. Which two terms are there? See, very simple, 5 root x and 4 root x, right? Because 5 root x minus 4 root x, it is nothing but what your root x, and their multiplication 5 root x into 4 root x, you have got 5 4s are 20, root x into root x, x. Whenever there is a plus in the denominator, you have to decide the subtraction in the numerator. Subtraction of the two terms, right? मग खाली जर प्लस असेल तर वर अशा दोन टर्मचा विचार करायचा कि देयर शुड बी अ सबट्रैक्शन, राइट. अगर नीचे प्लस है तो ऊपर क्या डिसाइड करेंगे, देयर इज अ सबट्रैक्शन. तो ऊपर माइनस का सोचेंगे, दो टर्म का सबट्रैक्शन सोचेंगे, isn't it? So here very simple again, tan inverse root x you can write as a 5 root x minus 4 root x. Here 1 it is already there, and this you can write as a 20x, isn't it? 1 it is strictly there, the multiplication of a two term is there, therefore directly what is the simplified form, tan inverse of 5 root x minus tan inverse of 4 root x, isn't it? Now again differentiate. See, this is u. What is the derivative of a tan inverse u? Again 1 upon 1 plus u square means 1 upon 1 plus इसका स्क्वायर करना है. What is the square of this? 5 का स्क्वायर 25, रूट x का स्क्वायर x, और इसकी डेरिवेटिव लेना है. Again the 5 remain as it is. What is the derivative of a root x? That is 1 upon 2 root x, isn't it? So this write in the bracket. Here again same case. Here again substitute u. What is the derivative of a tan inverse u? 1 upon 1 plus इसका स्क्वायर करना है. What is the square of this? That is 16x. 4 का स्क्वायर 16, root x का स्क्वायर x. Again 4 remain as it is. What is the derivative of a root x? That is 1 upon 2 root x. Right? Therefore 1 upon 2 root x you can take common, and what is remaining 5 divided by 1 plus 25x, and here you can write 4 divided by 1 plus 16x. Right? No need to make again the simplification. ये simplify करना जरूरी नहीं है, यहाँ तक ही कर दिया तो चलेगा. Right? यहाँ तक ही stop कर दो प्रॉब्लम को, ये जरूरी नहीं. Right? So this is about the solution of this problem. Right? तर हे असं करायचं इथे लक्षात ठेवा सगळ्यांनी. हा चौथा टाइप आहे आणि या फॉर्म्युलाचं करायचं आहे. आणि हा फार्मूला फर्स्ट क्या करना है, उसको ध्यान में बिठाना है पहले. व्हाट इज द फार्मूला? अगर वो फार्मूला माइंड में बैठ गया, यानी व्हाट यू हैव टू डू एक्चुअली, यानी हमको क्या करना है ये अगर डिसाइड कर लिया तो यू कैन मैनेज द एनी प्रॉब्लम, isn't it? So here one should be strictly there. Whatever the term added, you want it's a multiplication, and if your problem it is in this form, then you write the simplified form and do the problem. Right? So I have given the 4 type of a problem on this formula. See. Now the second one. Again, the problem depending upon. See. इसके 4 टाइप लिए और एक पहला टाइप लिया था अपन ने. Now the problem depending upon. Here. Problem depending upon the formula sin 2x is equal to 2 sin x cos x, and here again cos 2x, that is cos square x minus sin square x. Right? Again 1 minus cos x, it is equal to 2 sin square x by 2. 1 plus cos x, 2 cos square x by 2. Here again 1 plus sin x. This you can write as a cos x by 2 minus sin x by 2 whole square. And here again 1 plus tan x. If there is a minus, plus, there is a plus, and if there is a minus, there is a minus. Again 1 plus tan x divided by 1 minus tan x. It is equal to tan of pi by 4. Compulsory term. अगर ऊपर प्लस है तो यहाँ भी प्लस देना, और वट एवर द एंगल, x है तो x लिखना, 2x है तो 2x लिखना, 3x है तो 3x लिखना. So now the problem depending upon this formula. First, try to understand this formula and their bifurcation. How will you bifurcate the formula according to the problem? Whatever the problem given, you have to bifurcate that formula. Not simple, that is sin 2x, you have to, don't remember only 2 sin x cos x. Now see here, what is the formula here? Sin 2x. it is equal to what here? 2 sin x cos x. Right? Means they have made the half of this sign. Suppose you write sin x. Again you can bifurcate this. What is the half of this x? That is 2 sin x by 2 and cos x by 2. And here your book or anywhere they have given the name that is half angle formulas. But you can bifurcate n times also. You can bifurcate this formula. This is sin 2x, 2 sin x cos x. Sin x, 2 sin x by 2 cos x by 2. If you write sin 3x, the triple angle formula that is different. But according to this you can bifurcate. That is 2 sin 3x by 2 cos 3x by 2. Suppose sin 4x. You can write as a 2 sin 2x cos 2x. Right? Suppose sin 5x. Then you can write as a 2 sin 5x by 2 cos 5x by 2. Right? So, in the same way, suppose sin nx, then you can write 2 sin nx by 2 and cos nx by 2. Right? So, in this way, you can bifurcate the formula according to the problem, isn't it? So, whatever the problem it is given, by that way, you have to bifurcate this formula. Only don't remember this, isn't it? You can change this, you can bifurcate this, right? The second one, see here, that is cos 2x. Again, what is cos 2x? What is the formula? There are the 4 formulas of the cos 2x, but whatever the problem we are doing now, only this formula it is required. There are the 4 formulas of the cos 2x, cos square x minus sin square x. Second one, 1 minus 2 sin square x. Third one, 2 cos square x minus 1. And the fourth one, 1 minus tan square x divided by 1 plus tan square x. Isn't it? There are the 4 formulas, but here, in this problem, we required only this, cos square x minus sin square x. Right? Now here, again, suppose cos x. 2x, it is converted into x, means half we have taken. Now here you can write as a cos square x by 2 minus sin square x by 2. Right? Again, cos 3x. Cos square 3x by 2 minus sin square 3x by 2. Right? In the same way, cos nx, you can write as a cos square nx by 2 minus sin square nx by 2. Right? So, you can bifurcate again like this. These 2 formulas, I have given the name, that is the evergreen formula. Your second paper, in every problem or in every page, you require this formula, these 2 formulas, that is 1 minus cos x. It is equal to 2 sin square x by 2. That formula, you have find it from this here. 1 cos 2x, it is nothing but what here, 1 minus 2 sin square x. And here suppose you write the term 2 sin square x, it is equal to 1 minus cos 2x. Therefore, 1 minus cos 2x, it is nothing but what here, 2 sin square x. If there is a 2x, then there is a x. If there is a x, then what here, there is x by 2. 1 minus cos 2x, again you can write as a 2 sin square x. 1 minus cos 3x you can write as a 2 sin square 3x by 2. 1 minus cos 4x you can write as a 2 sin square 2x. Right? In this way, 1 minus cos nx you can write as a 2 sin square nx by 2. So, if there is a minus, then here you have to write sin. 1 minus cos x, 2 sin square x by 2. 1 minus cos 2x, 2 sin square x. 1 minus cos 3x, 2 sin square 3x by 2. 1 minus cos 4x, 2 sin square 2x. 1 minus cos nx, 2 sin square nx by 2. Isn't it? So this is called as an evergreen formula. I have given the name. So don't find in the book, don't see in the books, isn't it? Anywhere you will not get this, the name, that is the evergreen formula. Why I have given the name evergreen formula? Because in your second paper, from the first page to the last page, it is very, very useful, infinitely useful, isn't it? So, you have to remember this formula very well, that is 1 minus cos x, 2 sin square x by 2. 1 minus cos 2x, 2 sin square x. Similarly, 1 plus cos x, see here. 1 plus cos x, again second evergreen formula, 1 plus cos x, that is whenever there is a plus, this is cos, 2 cos square x by 2. This formula again we have find it from the cos 2x. What is the formula, third formula of a cos 2x? that is 2 cos square x minus 1. If you transfer those minus 1 to this side, 1 plus cos 2x, it is equal to 2 cos square x, right? Therefore, if there is a 2x, then this is x. If there is a x, see, 1 plus cos x, 2 cos square x by 2. 1 plus cos 2x, 2 cos square x, see, 1 plus cos 2x, 2 cos square x, right? Again, 1 plus cos 3x, 2 cos square 3x by 2. 1 plus cos 4x, 2 cos square 2x. 1 plus cos 5x, 2 cos square 5x by 2. Right? Again in this way, 1 plus cos nx, you can write as a 2 cos square nx by 2. So in this way, you can bifurcate this formula. Right? Again in the same way, this formula also you can bifurcate. See, how will you make the bifurcation? When you write 1 plus sin 2x, see, 1 plus sin 2x. What is the meaning of this? What is 1? 1 you can write as a sin square x plus cos square x. And the formula of a sin 2x, that is 2 sin x cos x. And again, if you observe this, this is the perfect square of sin x plus cos x. But every time, you have to write as a cos x plus sin x. Every time, write this. You can write sin x plus cos x, but for the example, while doing the problem, it is useful, that is cos x plus sin x whole square, isn't it? Similarly, 1 plus sin x, since there is a 2x, you can write x. 1 plus sin x you can write as a cos x by 2 plus sin x by 2 whole square. Again, 1 plus sin 3x, you can write as a cos 3x by 2 plus sin 3x by 2 whole square. Right? If 4x, there is a 2x. If 5x, 5x by 2. If 6x, 3x, isn't it? In this way, you can bifurcate this formula. And if there is a minus sign, here there is a minus sign, here also minus. If minus, here minus, here minus, here. Isn't it? Now here again, the last one, see, tan of pi by 4 plus x. What is the formula? What is the formula of a tan a plus b? Tan a plus b, it is nothing but tan a plus tan b divided by 1 minus tan a into tan b. Isn't it? Therefore, what is tan pi by 4? 1 plus tan x. Here again, 1 minus. What is tan by 4? 1. 1 into tan x. Right? Therefore, tan of pi by 4 plus x, you can write as a 1 plus tan x divided by 1 minus tan x, or conversely, 1 plus tan x divided by 1 minus tan x, you can write like this, tan of pi by 4 plus x. Right? So, if there is a in the numerator plus, you have to give plus. Whatever the angle, that you have to write, and pi by 4, it is the compulsory term. Therefore, 1 minus, suppose, tan 3x by 2 divided by 1 plus tan 3x by 2. How will you write this? Tan of your pi by 4. This is the compulsory term. What is the sign of a numerator here? Minus. Give minus sign. What is the angle? 3x by 2. So you can write the formula like this. Suppose 1 plus tan 5x, 1 minus tan 5x. Again, how will you write this? Tan of pi by 4 compulsory term. In the numerator there is a plus sign, therefore give plus. And what is the angle? 5x. You have to write 5x, isn't it? So, in this way, you have to remember all these formulas. And depending upon all these formulas, there are the problems, isn't it? So here, I will take the problem C on this formula. 5 type of problems again. You can make many problems. You can construct yourself the many problem here. So the first one, y is equal to tan inverse of sin x divided by 1 minus cos x. Second one, y is equal to tan inverse sin 3x divided by 1 plus cos 3x. third one, y is equal to tan inverse of 1 minus cos 5x divided by 1 plus cos 5x. ये साइन तुम ऊपर नीचे कर सकते हैं, यहाँ प्लस दे सकते हैं, यहाँ माइनस दे सकते हैं, यहाँ प्लस यहाँ माइनस, कुछ भी कंस्ट्रक्ट कर सकते हैं, राइट? दैट इज अगेन 1 plus sin x, 1 plus 1 minus sin x, 1 plus sin x. And again the fifth one, see, y is equal to tan inverse cos x divided by cos 3x divided by 1 plus sin x. Now see, there are the 5 types of a problem, and again we have to take all the problems here, 5. So the first one, right? Now y is equal to tan inverse sin x divided by 1 minus cos x. You have to remember this evergreen formula. I have given the name, that is the evergreen formula. This is double angle, but you can bifurcate. This is double angle, again you can bifurcate, right? All the bifurcation I have already told you. The first one here. Here again, since there is a term that is sin x and 1 minus cos x, and outside that is the tan inverse, your way, you have to think of how will you get the tan of something in the bracket, right? ऐसा सोचने का, यहाँ tan कैसे आएगा? So that tan inverse and tan get cancelled, you will get the result. And whatever the result you will get, you can find out the derivative of that function. काय विचार करायचा आहे तुम्ही? असा विचार करायचा इथे की काहीतरी tan of something आलं पाहिजे. Tan of something म्हणजेच tan inverse आणि tan get cancel. Whatever the something it is remain, you can find out the derivative. So it's very simple again. Tan inverse. You can write as a sin x. You can write as a see sin 2x 2 sin x cos x. Sin x you can write as a 2 sin x by 2 cos x by 2. And again, what is the evergreen formula? 1 minus cos x you can write as a 2 sin square x by 2. Right? Again 2 to get cancelled. 1 sin x by 2 get cancelled. Here you have got tan inverse of cos x by 2 divided by sin x by 2. Cot आला तरी घाबरायची गरज नाही. If you have got cot in place of tan, suppose you have got cot, there is no need to make any because see here, that is cot you can convert in the form of a tan, right, by taking the help of a pi by 2. Therefore see what you have to do. This is tan inverse of cot x by 2, and cot x by 2 you can convert in the form of a, that is tan inverse tan of pi by 2. You can take the help. Cot you can convert in the form of a tan by taking the help of a pi by 2. Pi by 2 minus x by 2. Right? Therefore here again tan inverse tan get cancelled. Pi by 2 minus x by 2 and dy by dx. It is, what is the derivative? 0. And what is the derivative here? Minus 1 by 2. Therefore here you have got the first one, that is tan inverse sin x divided by 1 minus cos x. That is nothing but sin x you can write as a 2 sin x by 2 cos x by 2. Here you have to use the evergreen formula 2 sin square x by 2. 2 to get cancel. Sin x by 2 sin x by 2 get cancel. Cos x by 2 divided by sin x by 2. तो ये कुछ चिंता करने की जरूरत नहीं है, इसको कुछ डरने की जरूरत नहीं है, because the cot you can convert in the form of a tan. So you have got the cot, no need to write, isn't it? Therefore here in place of cot you can convert cot in the form of a tan by taking the help of a pi by 2. Therefore cot x by 2 you can write as a tan pi by 2 minus x by 2. राइट? याला असं काही घाबरायची गरज नाही, कारण कॉटला आपल्याला टॅन करताच येते, राइट? आणि या पद्धतीने दिस इज व्हेरी सिंपल. पाय बाय 2 कॉन्स्टंट 0 अँड मायनस एक्स बाय 2 चे डेरिव्हेटिव्ह मायनस 1 बाय 2, राइट? अगेन आय विल टेक द सेकंड वन. सी second, that is y is equal to tan inverse same type, 3x 1 plus cos 3x. Again how will you write this here? Tan inverse sin 3x. Which formula you can use? That is 2 sin 3. Don't use the triple angle, sin 3x by 2 only the bifurcation cos 3x by 2. And you know the second evergreen formula, 1 plus cos 3x you can write as a 2 cos square 3x by 2. See, 2 to get cancel. Cos 3x by 2, cos 3x by 2 get cancel. Y is equal to tan inverse. Here, sin by cos, sin 3x by 2 divided by cos 3x by 2, you have got as a tan 3x by 2. Tan inverse tan get cancel. Here again, 3x by 2 and the derivative of a 3x by 2, it is nothing but the 3 by 2. The derivative of a x, that is equal to 1. So this is the second one, isn't it? Again the third one, very simple. Third problem, see the third one. That is y is equal to tan inverse of root of 1 minus cos 5x divided by 1 plus cos 5x. Again very simple. See, again you have to use the evergreen formula. 1 minus cos 5x you can write as a 2 sin square 5x divided by 2. And here again 1 plus cos 5x, 2 cos square 5x by 2. 2 to get cancelled. Out of the root you have got as a sin 5x by 2. Because the square root of sin square you can write as a sin 5x by 2. And here again cos 5x by 2. Sin divided by cos you can write as a tan 5x by 2. Again tan inverse tan get cancelled. What is remain here? Y is equal to tan inverse tan get cancelled 5x by 2. And here dy by dx, it is nothing but what you have. This is about the third one. See, now I will take the fourth one. Here, fourth. Fourth one, that is y is equal to tan inverse root of 1 minus sin x divided by 1 plus sin x. Right? Now y is equal to tan inverse. See again, what is the formula? 1 minus sin x you can write as a cos x by 2 minus sin x by 2 whole square. Use the same formula here, cos x by 2 minus sin x by 2 whole square. And here again same, cos x by 2 plus sin x by 2 whole square. Right? Now again, out of the root, you can take the square root here, tan inverse. This is cos x by 2 minus sin x by 2 divided by cos x by 2 plus sin x by 2. Right? Now again, how will you bring the tan function here? For that purpose, see what you have to do. Divide both numerator and denominator by cos x by 2. Right? म्हणजे कुठेतरी इथे tan येण्याची शक्यता आहे. Right? Here you will get the tan function. See y is equal to again tan inverse. When you divide it with cos x by 2, 1. Sin x by 2 divided by cos x by 2, tan x by 2. Here again, cos x by 2 divided by cos x by 2, 1. And here again we have got tan x by 2. Again I have already told you this formula, that is y is equal to tan inverse. See here, right? 1 minus tan x by 2, 1 plus tan x by 2. You can write as a tan of pi by 4, it is the compulsory term. Numerator में क्या है? Minus, u minus. And what is the angle here? X by 2. So again, see, tan inverse tan get cancelled. Pi by 4 minus x by 2. Therefore, dy by dx, it is equal to, what is the derivative of a pi by 4? Constant. It is always equal to 0. Minus 1 by 2 remain as it is. And the derivative of a x, that is equal to 1. Therefore, here you have got, that is minus 1 by 2. Isn't it? So again, the fourth I have done here. Now the fifth one, see. Fifth. That is y is equal to cos 3x tan inverse of cos 3x divided by 1 plus sin 3x. See this one. Again, y is equal to tan inverse. Cos 3x you can write as a c. Cos square 3x by 2 minus sin square 3x by 2. Right? And you know, 1 plus sin 3x you can write as a cos 3x by 2 plus sin 3x by 2 whole square. Right? Give such a brief bracket. Again, y is equal to c. Right? Tan inverse. Can you factorize a square minus b square? Means what here? A minus b, a plus b. You can factor, you can find out the factor of the numerator, that is cos 3x by 2 minus sin 3x by 2. This is one of the factor. Another here, cos 3x by 2 plus sin 3x by 2. Right? This is another factor, divided by cos 3x by 2 plus sin 3x by 2 whole square. Right? Again, bracket. One of the factor get cancelled, cos 3x by 2 plus sin 3x by 2 whole square. And here cos 3x by 2 plus sin 3x by 2, one bracket get cancelled. What is remains here? Tan inverse. Cos 3x by 2 minus sin 3x by 2 divided by cos 3x by 2 plus sin 3x by 2. Again, to get the function tan, what you have to do? Divide by cos 3x by 2. When you divide it with cos 3x by 2, you have got tan inverse. Cos 3x by 2, cos 3x by 2 get cancelled. Here tan 3x by 2. Here again 1. Again plus tan 3x by 2. Again you know the formula. 1 minus tan, 1 plus tan. That is y is equal to tan inverse. Again tan of pi by 4 is the compulsory term. If the sign of a numerator, that is minus, give the minus sign, and whatever the angle, what is the angle? That is 3x by 2. Right? So tan inverse tan get cancelled. Right? Tan inverse tan get cancelled. What is remain here? Y is equal to pi by 4 minus 3x by 2. And what is the derivative here? That is dy by dx. Pi by 4 0. Right? Again minus 3 by 2 remain as it is, and the derivative of x1. Therefore the result is minus 3. Therefore again we have done the problem, that is the problem depending upon these formulas, isn't it? So you can bifurcate the angle. You can write x, 2x, 2x, 3x, 3x, 4x, 4x, 5x, 5x, right? X by 2 also, right? Here also you can bifurcate the angle. Here also you can bifurcate the angle. You can change the sign. Minus you can write as a plus. Here you can write minus. Here plus, here minus. So many problems you can construct yourself. So this is about the third part of the inverse trigonometric function. Again I am continuing the fourth part of the inverse trigonometric function in the next session, in the next video. So please the student, if you like my video, share it and subscribe my channel, that is the Patil Madam's Krishna Coaching Classes.